Let's continue our discussion on factoring and distributing that we started last week. I'm going to write an expression, 6 plus 9. I could think of that as 9 plus 6. What have I changed? I've just changed the order, but have I changed the answer? No, 6 plus 9 is equal to 15. 9 plus 6 is equal to 15. When I'm adding two numbers, it doesn't matter the order that those numbers come. I could also write this as 9 minus negative 6, or 6 minus negative 9. If you use your calculator, you'll see that both of these are also 15. Why? Because 9 minus, when we subtract a negative number, we're performing the opposite operation. The opposite of subtraction would be addition. So rather than subtracting a negative, I'm adding a positive. Same here. Okay. Now let's think of this even in a different way. Let's go back to our 6 plus 9. I might be able to notice that both 6 and 9 are multiples of 3, right? 3, 6, 9, 12, etc. So both 6 and 9 are multiples of 3. So I might be able to rewrite this as 3 times 2, right? Because 6 is 3 times 2, plus 9 is, 3 times 3. Well, let's just see if this is truly equal. 6 plus 9 is equal to 15. 3 times 2 plus 3 times 3, well, 3 times 2 is 6. 3 times 3 is 9. If I add those together, I get 15. So we're just thinking of other ways to rewrite numbers. That's part of being a mathematician, is seeing patterns in numbers and being able to think flexibly about numbers. Now I could take this even further. I could see that, well, in both of these terms, I have a 3, right? I'm multiplying 3 times 2 and 3 times 3. So I might say, well, I could rewrite this as 3 times the sum of 2 plus 3. So 2 plus 3, right? What have I done? Well, I've factored out a common factor of 3. In both of these terms, I'm multiplying a number by 3. So 3 is my common factor, which I can factor out of my expression. Right here. And what am I left with? Well, 2 plus 3. Now let's see if this is in fact equivalent. So if I have 3 times 2 plus 3. Well, by the order of operations, I would start with what's in parentheses. 2 plus 3 is 5 times 3, right? 3 times 2 plus 5. 3 times 5 is 15. Or you could put the whole thing in your calculator and you would see that this is equal to 15. Okay. So we call this, just a quick second, factoring. I'm taking the common factor from each term and I'm putting that on the, basically on the outside. I'm taking out a common factor and then multiplying it by the rest, by the remaining terms. So let's try a new one. Let's say I have 15 plus 30. Well, I could see that both 15 and 30 are multiples of 15. So I could rewrite this as 15 times 1 plus 15 times 2. Well, I have in both cases this common factor of 15 that I could remove And then the remaining terms, 1 and 2, notice that this is a plus, I can put in parentheses here. So let's see if all of these are equal. 15 plus 30 is equal to 45. 15 times 1 plus 15 times 2. 15 times 1 is 15. 15 times 2 is 30. 15 plus 30 is 45. Now, let's look at this. 15 times the sum of 1 plus 2. Well, 1 plus 2 is 3 times 15 is 45. So I've found that I could write this expression as 15 plus 30, as 15 times 1 plus 15 times 2, or as 15 times the sum of 1 plus 2. In all three cases, I end up with the same answer, right? These are all equivalent expressions. Now, what happens if I'm starting out with an expression that's already been factored? Okay. So I have 8 times the sum of 2 plus 3. Now, I know if I put this in the calculator, or if I use the order of operations to simplify, I would have 8 times 5 is equal to 40, right? So if you just do this in one step in your calculator, this is 40. But let's see how else I could solve this. So it might ask me to simplify. Well, if I do the opposite of the factoring, and I distribute this factor of 8 to each of my terms inside my parentheses. 8 times 2 plus 8 times 3. 8 times 2 is 16. 8 times 3 is 24. If I add those together, I get 40. So this is the opposite operation of factoring. We call this distributing. Let's try another one. 9 times the sum of 2, or the difference, 2 minus 1. Okay. If I do this in my calculator, I find that this is equal to 18. I can also use the order of operations. 2 minus 1 is 1 times 9. Whoops, this is not. This is equal to 9. 9 times 1 is 9. Now let's try this by distributing. I distribute 9 times 2 minus 9 times 1. 9 times 2 is 18. 9 times 1 is 9. 18 minus 9 is 9. Now you might say, well, Ms. Johnson, I can just do these all easily in the calculator. I don't need to distribute all of this. But what you're going to find in algebra is you're going to get something like this. 4 times x plus 3. 4 times the sum of x plus 3. Okay? And you can't do this in this calculator. In this case, you're going to have to distribute in order to simplify this expression. 4 times x plus 4 times 3. 4 times x is 4x. 4 times 3 is 12. And this would be my simplified expression. There's no way to do this in your calculator. This is something you're going to have to be able to do through distribution. And this is what has been something that's been very difficult for algebra students this year. Now, if I do another problem, let's say I do 6 times x minus 4. Same process, 6 times x minus 6 times 4. 6 times x is 6x minus 6 times 4 is 24. And this would be your simplified expression. Now let's try a negative. Negative 3 times x minus 2. You need to distribute this whole term. So negative 3 times x is negative 3 times x. Bring down this minus negative 3 times 2. Well, this is negative 3 times x minus negative 6. Well, when I subtract a negative, this becomes positive. So I will have negative 3x plus 6 as my simplified answer.